Hello everyone, this is Mike from Medical Models at med-ma.com, and I want to do a short video about Dicom data with an emphasis on anonymizing it and loading it into medical imaging software like 3D Slicer. So to get started, Dicom stands for Digital Imaging and Communications in Medicine. This is their website, dicom.nema.org. I'll have the relevant websites linked down below. For our purposes, to initially understand Dicom data, it's a standard for MRI, CT scans, any related medical imaging, X-rays, things like that. And it's a file format along with the standard that can be used for transferring data over PACS, things like that. So first thing to look at is the data dictionary. This will, if you click here, it brings up this PDF here, which defines the metadata information, also called header file. So if you have any slice of a scan and you open up and look at the information about it, you'll have the tags, which are two sets of 4-digit hexadecimal codes here, and then the relevant name keyword. And so there'll be values in the file that we'll look at in a bit that relate to it. But this is the initial place to start to look at what all these different values and tags refer to as a reference. And if you want more information about any one of these, for example, let's look at 20. Okay, obviously there's a lot of values. Most of these aren't going to be relevant. Most of them aren't going to be included in any particular scan. But I'll look at a common important one for the purposes of creating models and 3D printed models is one like this. Let's go with image orientation. So if you want to know what that means, you can go to a website here, Dicom Lookup. This is dicomlookup.com. And if you want to put in this tag, say 2032, I believe it was, it pulls up the description. So this defines what 2032 tag image position patient means. So it's the coordinates of the upper left-hand corner center of the first voxel of the frame. And that will change for each slice. So that is briefly what the tags mean and how to find more information about them if you need to know what you're looking at in a file. And before we go and look at some actual data, one other important thing is to understand anonymizing data, and what that is removing all relevant information that could be used to trace back to you or the person that was scanned. And so if you go to this website, which will be linked below, and then you click on this PDF, it brings up this document. It's a short overview. But the important thing is to understand what proper de-identification of data looks like. And the way they have it defined here, you can look, is basically to remove anything that is related to the person. So obvious things like names, but also addresses, locations, age, especially if you're over the age of 89, then you're in a sensitive group. Telephone numbers, all this information can often be in Dicom data. Social security numbers, that will usually be in there as well, so you don't want to be sending that to someone when you are, if you want to send your Dicom data to someone. So let's look at some data. So here's a scan I got a long time ago of my feet. This is typically how you'll get it, is as a CD. And so this has a bunch of other files here which we don't really care about. These are basically part of the program that is on the CD to load and view data. I don't typically bother with those. But what I am interested in is what's in these folders. So this CD, for some reason, had a scan of an 80-year-old male's head. Had nothing to do with my feet. I think it was just some mistake by the technician. But this has 2 folders. And so these are 2 different scans of my feet. It has a dir file, which isn't useful for our needs. That has information about how the directory is organized. There's also 1 in each scan. So a lot of times you'll get multiple scans more than just 2. You may get 10 scans, and some of them only have 1 or 2 scans, 1 or 2 files. Those are typically scouts, which you don't care about. So you typically want the one with the most images if you're trying to create a volume of data. And so sometimes it can be difficult to figure out which one to use. One rough way of doing that is just to find the one that has the most slices or files in it. Also, they don't always have an extension .dcm. That's the typical extension, but that's not always the case. Certain programs require that extension to load in the data. Extensions are really just for Windows computers, but it's pretty common to have. But that can be a problem with certain programs. So I'm not actually going to load up this one because it has all my patient identifier data in it, such as my Social Security number, which I do not want to reveal to the world. So what I will do is open up a different scan, or sorry, this is the same scan, but it's been anonymized. I use MATLAB, but that's not necessary. Most people aren't going to bother with it. But here is a program called Fiji, which is also basically ImageJ. It's just a newer, updated version of it. And I'm going to load in this this whole scan. So the way it works is you go to that folder, you select one of the files, and then it can figure out how many files are in that folder and load them up for you. So here's a scan of both my feet, left and right. Just looking at this image, you may not be able to tell which is my left foot and my right foot. You may assume that the foot here is my left foot, and then this is my right foot. But that's assuming you're looking from superior down in the inferior direction. But if this is looking from the bottom, then this could be my right foot, and that can be my left foot. And sometimes when data gets read in the wrong order, you can actually have an inverted data, which can be a challenging situation to figure out. In an ideal world, you'll have something actually in the scan image that will signify if that's the left side or right side. And there's also typically letters in the scan itself or in the header file. But anyways, let's actually look at the header file or the metadata. So you can go show info or Control I, and this pulls up your Dicom tags and all the information. Now this has been anonymized since, of course, I don't want to reveal my Social Security number on YouTube. And there are quite a few values in here. So most of this has been removed at like the date, the time, the institution name, the physician name, my name, my date of birth. But important things are kept, such as your slice thickness. So that's 1 millimeter slice thickness. The spacing between slices, which is 0.5 millimeter, so these are overlapping. That's pretty common. The modality, so this is a CT scan. This is where it would say MRI or other types of scans. Other information that's important for reading in a scan is image number. Sometimes that's helpful. Oftentimes that lines up with, well, basically it's like the order of the scan. So this is a whole stack of images that are loaded up, and so this one probably is just taken from the last image in the scan. Image position patient, I believe that's what we looked at on the Dicom lookup. This is the XYZ position of the data. This is probably from the last slice, but this will change for every slice. The orientation, so I believe that's the first three numbers is your unit vector for the x direction, and the unit vector for the y direction, and then the unit vector for the z would be the cross product of that. Slice location, so yeah, this typically will line up with the z position of a slice. Let's actually do that. Let's look at a single slice and see if that helps. Look at this data more orderly. So there again, you have your image position, slice location. So I'm not entirely sure why this is different, but some programs may use your slice location to order images. That is not the best. Your rows and columns, that's your resolution. So it's a 512 by 512 scan, the in plane. You can see it here. Then you have your pixel spacing. This is important. This is your resolution for each slice. So 500 millimeters by 500 millimeters is this whole region here. This will not typically change between slices. I have had one scan where I believe it was the y-axis pixel spacing changed on every image. It was very unusual, but that's not going to happen very often. So for a volume to be well defined, the important things are your pixel spacing, your position of each one, and your spacing between slices. Now some programs use your slice thickness to define your z dimension. That is that's bad, I would say. I would say it's definitely better to use their spacing between slices, or even better is the image position. And so sometimes if you find your data is not loading up correctly, like you load up and it's stretched in one dimension, that's probably because it's using your slice thickness, or there's some other problem with the data. And that's something that can be fixed by changing these values, if you know what you're doing. So those are some of the important values, things to look for when you load up a scan. Now let's actually look at how to go about fixing scan data. So this is that same scan, I believe. This is a Dicom browser program. So it's a free program you can use to load in data. It's kind of cut off with the video capture here, but basically if you look at any one slice, it still gives you that same, let's just do this. It gives you the same information. So for each one, you can look at the tags. So a little bit cleaner interface. I'm not as familiar with this. I typically do all my anonymizing and fixing data in MATLAB. I just have some code that kind of automates the process. But most people don't want to buy MATLAB. But for example, I put in my foot as a name. So I did that in MATLAB, but this is where you could change those values. So if, for example, your typical data is going to have all this information here that you want to anonymize. So you can go in and basically select all of it. And this kind of overlaps the different image information on top of each other. So for each scan, there's a SOP class. So here we go, image position patient. So you can look at every single scan. It shows your position. So this one is just progressing in the z dimension, which is easy. Sometimes all three will change, and so if you wanted to calculate the difference between two images to get your slice spacing, for example, then it'd mean doing a calculation. But for example, if this was not anonymized and I wanted to remove my name, you can go in here and click clear. And so this is the action that the program will do to clear off the data. So if you went through and did that for all your information, then you can go in here and save it. I don't need to save this one, but create a new directory or new folder, put it in, and save out the data. This is also a way that you could fix data. For example, if you know your program uses slice thickness instead of slice spacing, and your slice thickness did not equal your slice spacing, which is often the case. That's the case in this scan here. So it's a 1 millimeter thick slice, and I'm trying to find the slice spacing. This scan didn't originally have that. I believe I added that in using MATLAB. I just am not seeing it at the moment. But anyway, say you know your program uses slice thickness, so you can just go in here and change this to 0.5. It's kind of cheating, but it may be what's necessary to fix some data. Okay, so say you did all that, you anonymize it, and maybe you had to fix a certain value. You save that as a new set of images, and then you want to load the data. So you can go into 3D Slicer and you can load in the Dicom data here. Oh, I did this before, so I'll just delete these. So let's say I wanted to look at that. That's a CT scan of my foot, and I will load this one up here. And so 3D Slicer will load up the data. It treats it as a volume, so it loads up each slice and creates a three-dimensional volume that you can look at and work with. Typically and traditionally, scans would be given as a folder of slices or images. Sometimes you will get a scan, which is a volume, so it's one file that's, say 30 or 40 megabytes, which is a bit better to work with. You don't have to deal with the potential of unordered slices not showing up correctly. Okay, I guess I need to select that. So it loads it in. And there we have my foot. So I can pan around. Oh, there we go. So there's my volume of data. And so you can move the sliders. These are your three orthogonal views. So you can check the data. Also very helpful is to look at the scan here, and this gives you the geometrical information you want. So pixel spacing, or voxel spacing, you could say, voxel size. So each voxel, which is a three-dimensional pixel, is 0.977 by 0.977 by 0.5 millimeters. This is the origin of the data. I think that's relative to some origin from the scanner. So typically not that important. You can clear that out by basically centering it around that, which, depending on what you're doing, it may or may not cause issues. There we go. So that's been centered. But that's loading the data in here, and then say you wanted to save this volume, typically with 3D Slicer, you're going to do that as a NRRD file. And so I'll just save it here, save it there. And yes, I've already done this. So this is saving the Dicom data as a 3D volume. And I will look at that. Let me see here. Okay, so oh, I think it was still working. Okay, so now it is. So if you open up your NRRD file in a text viewer, This is Notepad++. Probably might not work if you looked at it in a Notepad or something when Windows might crash. But this is what you get, and this is basically all that's left of your metadata. You have your size, your number of voxels, your dimensions. I believe this is your X, Y, and Z resolution overlaid on top of the orientation vector, I believe. And then you have your your origin. What this doesn't have is things like, is it an MRI or a CT scan, or is it a 3 Tesla or a 1.5 Tesla CT MRI scan, and various other information that you can get if you still have your original Dicom data. So it's one reason that it may be more helpful to send anonymized Dicom data versus an RRD file, which is anonymized. So anyways, that is a basic overview of Dicom data. There's a whole lot more, but for the purposes of creating models and loading data in, this should cover most of what you need and hopefully give you the tools to find anything else out that you need. Thanks for watching, and hopefully you found this helpful.